We all look up and see the stars, right?
Right.
Those pinpricks of light in the night sky.
Yeah.
But have you ever thought about like where they actually come from?
Oh, it's a fascinating story.
Their origin story.
Yeah, we've been looking at some excerpts from a podcast called How Are Stars Formed?
Oh.
From Cosmic Clouds to Shining Suns.
Oh, cool.
And it's really amazing, this journey of how these diffuse clouds of gas can eventually become these brilliant stars. And we're going to kind of take you through the key stages of that whole process.
I love it. A deep dive.
Hmm.
So like where does it all even begin?
Well, it all starts in these huge clouds of gas and dust that are scattered across space. And they're called nebulae.
Nebula.
And often they can be really cold and dark. But they're essentially the stellar nurseries of the universe.
Yeah.
And they're just these seemingly empty regions, but they're actually where all these stars are born.
So from like, I'm picturing like a cosmic dust bunny or something, but like
Yeah.
on a huge scale.
On a huge scale.
Yeah.
Yeah.
Okay, so we've got these huge clouds. What's the thing that kicks it all off?
Well, it's gravity.
Okay.
That's the fundamental force of attraction between objects. And gravity starts to pull all those gas and dust particles in the nebula closer together.
Okay.
And it doesn't pull uniformly, so you end up getting these like denser pockets forming within the cloud.
So you've got these denser pockets.
Yeah.
Then what happens?
Well, as more and more material gets pulled in, these pockets become even denser, more massive.
Right.
And they start to form what we call protostar.
Protostars.
Yeah, and what's really crucial is that as all this stuff is accumulating onto the protostar, the pressure and temperature at its core start to really increase.
So we go from a sprawling cloud to this like hot compressed center.
Exactly.
What's the like tipping point?
Well, the critical moment occurs when the core temperature hits something like 10 million degrees Celsius.
10 million degrees Celsius.
Yeah.
Wow.
And at that intense heat, something really incredible happens.
What?
Nuclear fusion ignites. And that same process, actually on a much grander scale in the early universe, that also played a role in actually forging many of the elements heavier than hydrogen and helium that make up everything around us.
Wow.
Including you.
That's amazing. Okay, nuclear fusion. That's when the star really like comes to life. So
Yeah.
tell me about that.
So at this immense pressure, immense heat, hydrogen atoms start to fuse together to form helium. And this releases an incredible amount of energy, which radiates outwards.
Okay.
And that outward energy, it actually creates this really crucial balance against the inward pull of gravity.
Okay.
And that stabilizes the young star and allows it to start shining steadily. And that's like its official on switch.
So cool. Now, this whole process, it doesn't just happen like that, does it?
No, star formation is a really long process.
Right.
It can take millions, sometimes even tens of millions of years.
Really?
Yeah, and what's kind of interesting is that the timescale can vary depending on the mass of the star. So bigger, more massive stars tend to form much quicker. Okay.
But they have much shorter, more dramatic lives.
Right.
Whereas smaller stars, they take much longer to form, but they can live for like billions and billions of years. Do you think the rate of star formation in the universe, does it change over time? Like what kind of factors might affect that?
Ooh, that's a good question.
Yeah.
So once a star is born and this fusion engine is running, what's its main activity?
Well, once it hits that point of stability, it enters what we call its main life phase. And what it's doing is mainly converting hydrogen into helium
Right.
and radiating energy in the form of light and heat. That's the starlight that we see.
Yeah.
And this stable period can last for the vast majority of a star's life.
Okay.
And as our source was saying, it's during this period that you can potentially get planetary systems forming around these young stars.
Oh, wow.
Yeah. And our own sun, the star we know so well, originated from a nebula billions of years ago. It went through this exact same process.
It really makes you think differently about the stars that you see.
Like when you look up, you realize that that tiny speck of light went through this incredible journey.
Yeah.
It started as like a little speck in a dark, cold cloud, got pulled together by gravity, and then culminated in this powerful nuclear fusion.
It's pretty amazing. And it kind of makes you think about, the universe is so vast.
Yeah,
And these processes of star formation, they're happening all the time
right.
in countless nebulae throughout the universe. So new suns and potentially even new worlds are constantly being created
Yeah.
right now at this very moment.
Wow.
What are the implications of that?
That is something to ponder.